Have you ever taken apart a computer, cell phone, or any electronic device? What did you see? Probably a thin green board with tiny components attached to it that look like they are connected by lines. That's a printed circuit board. The lines on the board are paths of copper called tracks. They conduct electricity to copper pads. The electrical components are fused to the pads with a low-melting metal alloy called solder. These tracks, pads, and components make up the electrical circuits that run your device. Many products in your home and school rely on printed circuit boards, so it's a good thing they can be mass-produced. Let's take a look. Engineers design a circuit pattern that accounts for the size of the device, how many components the board must include, and how they will connect. Printed circuit boards start as sheets of substrate, usually fiberglass that is laminated in a very thin layer of copper called a seed layer. The substrate is coated with a photosensitive film called a photoresist. This photoresist is exposed to ultraviolet light that has passed through a stencil-like circuit pattern called a photomask. The photoresist in the part not covered by the photomask melts and disappears. This creates a groove that exposes the copper seed layer. Next, these grooves are filled in with more copper through electroplating. In this process, the printed circuit board and copper rods are submerged in an electrolyte solution. The copper seed layer is the cathode, while the copper rods serve as the anodes. When electric current is applied, the copper rods ionize. The resulting copper cations in the solution are then reduced at the cathode. Once the desired amount of copper is deposited in the grooves, the rest of the photoresist is removed, and the seed layer underneath of it is etched off. What remains are the copper-filled cavities, which have become the tracks and pads of the printed circuit board. Okay, but how does it become green? That's the solder mask, which is a final coating applied to insulate the copper tracks and shield them from excess solder as components are attached to the board. As electronic devices get smaller and smaller, engineers must figure out how to design smaller circuit boards. But simply miniaturizing electronic components might not make them tiny enough. At that point, nanotechnology will be required. So, what is nanotechnology?